our PVT lab simulator mounted using the DOSBox. And if you want to know how to do that, basically the instructions on how to load the program is just given here in your lab manual. So we are going to do the lab number 2 from your lab manual. That's the saturation pressure of a binary system using the PVT lab simulator. So what we did, I just wrote this command on my DOSBox and then I opened the PVT lab simulator. So the first step is to verify and record the initial conditions, pressure, volume, and temperature, and composition. So in my Excel, I say the initial condition, okay? So I want to know first the composition, okay? So I say this is my composition. And then the composition, to know what that is, if you remember, we say we are using F10, function F10, and it says I have N-butane, okay? And that's 100% N-butane. So this is my initial condition, and what I have, this is the composition, so I would have the N-butane, NC4, and C4, and as I said, we are going to look at the CO2, okay? And if you remember, we said we can have the NC4 in the liquid phase, which we show with small x, and gas phase, which we show in the with the y's. Again, the CO2 could be in the liquid or in the gas phase, okay? Going to merge this too. And I'm going to merge this as well. Okay. And this as, oops, not this. So initially I have 100% of NC4, I have 0% of gas, and I have 0% of the CO2. So I need to find the pressure as well. So to find the pressure, I'm going to press F2 to operate the valve. I'm going to press F2 to operate the valve, and I'm going to open valve 8. So the pressure, the initial pressure is 2000. So these are measured at, so this is my pressure at 2000 psi. So at 2000 psi, I have NC4, 100% liquid, and I don't have any CO2. Okay, so this is my initial condition. Also, my initial, also the temperature, I would like to collect the temperature as well. So the temperature is 71.6, okay? So temperature, I got it to be 71.6. The composition, NC4, at 2000 psi, which is in initial condition, it's all liquid, I don't have any gas. So if you remember, to generate this two-phase, let me see if I have it here now. To generate the phase envelope of the pressure composition diagram, what I need is first to find the bubble point and dew point of this pure component where I don't have any CO2 added. So to do that, if you remember from our lab number 1, I'm going to open valve 9, okay? And I'm going to remove the mercury till I get to the bubble point. And also here for the initial condition, before we forget, the volume of liquid is 10 cc. That's another important information that we wanted to have, okay? So here basically it says we need to find the bubble point and dew point of N-butane when we have 0% CO2. That's our case. And it says if you remove 100% see. Okay, I was thinking that it gives us in the table. I did have the volumes required, but that's fine. We can find that. So we are going to find the bubble point. So I'm going to remove 1 cc. So 1 cc was too much. As I said here, we don't worry about the measurements, this calculations. We just need to find the bubble point. And every time we add or we remove mercury from the cell, we have to shake it. So I press F6 to shake this cell with the LC pump. Okay. And as you can see, every time you do it, the numbers will be changed. So it's too much. So I removed too much. So 1 was too much. I'm going to inject back 0.5. So 1 cc was too much. So I'm going to shake it again. Remember, if you don't shake it, the numbers that you were getting would be completely wrong. So I'm going to shake that again. So here I'm not collecting any information because what I need to do is to just find the bubble point. So I'm going to do one more time. So this is 0.04. So I'm going to inject 0.042 back. So I'm looking at the amount of gas that's been left, and I try to just proportionally inject mercury to get rid of that. And I'm going to press F6 again. Remember, every time we add or we remove the mercury, we need to press F6 to shake the cell and to bring the system to the equilibrium condition. Okay. Okay. So we are very close. I do F5. This time I'm going to inject 0.004. I'm going to shake the cell. Okay, so now I got to the point that the volume of the gas is 0.001. That's the smallest amount of gas that we can detect. So this is basically our bubble point pressure for this pure N-butane. And as you know, the dew point pressure would be exactly the same, so I'm not worried about that. So at this time, the pressure we measured is 32.569. Okay, that's our pressure. And I'm going to press F10. And press F10. So it gives me the composition. I have 100% of the N-butane in the liquid phase and 100% of N-butane in the gas phase. I don't have any CO2. Okay. So that's my first step. I did find a mixture. I did generate a mixture of 100% N-butane, and I found the bubble point and pressure and the composition. So I'm done with this part. So what I can do is to just press escape. Okay. I do press escape again. It says terminate the program. I say yes, and I come back to the program again. Okay. It says, do you want to keep the log? I say no. So again, as I said, in this experiment, you are going to perform the lab in using the total. So every time that I do the experiment, find the bubble point and mixture, I'm just going to pour everything out and come back with the fresh N-butane. So again, to just make sure I have loaded the right program, again, I have 100% N-butane. So this is all N-butane. Temperature is 71.6. And I'm going to open valve 8. The pressure is 2000. So all the initial conditions are met. And I have the 10 cc of the liquid. Okay. So now the first step, I'm going to generate a mixture of 10% CO2. So I'm done with the mixture of 100% N-butane. Now I'm going to generate a mixture of 10% CO2, 90% N-butane. And for that, as you remember, we said we are going to go to the table 4A. Okay, this is table 4A. Table 4A. For a mixture of 10% CO2, 90% N-butane, I need to add 0.57 cc's of CO2. Okay, I need to add 0.57 cc's of CO2 to this visual cell. This is my CO2 tank. Okay, the way it works is first I remove 0.57 cc's of mercury from this visual cell to open a space, and then I'm going to inject that 0.57 cc's of mercury into my CO2 tank to send the CO2 here. So if I inject 0.57 cc's here, the exact number will go from the other side. So here I have the liquid CO2. So the same amount that I'm going to inject into the cell is going to go here. So first, to do that, I need to open valve 9. Okay, so I press F2. I open valve 9. So I connect my hand pump to this. I want to remove, so I'm going to mercury, so I'm going to connect this from the top to the CO2 tank as well. So I'm going to use F2, open valve 11. I'm going to do F2 and open valve 4. Okay. So now the CO2 tank is connected to my visual cell and all the way to my hand pump. Okay. So now that I have everything connected, I'm going to use F5 and I'm going to remove minus 0.57. Enter once, enter twice. So I removed 0.57 cc's of mercury from this visual cell. Okay. Now what I'm going to do, I'm going to close valve 8, okay, because I want to disconnect it. I want to connect my hand pump to CO2 tank. So I'm going to open valve 1. So now my hand pump is connected to the CO2 tank and it's connected to the visual cell from the top. I have to close this because if this is open, then everything is connected. Okay, it's exactly like what we do in the lab. So if I inject mercury from hand pump, the mercury goes all the way, all these valves are closed. So it goes this way, goes to the CO2 tank, and it's like a piston. It pushes the CO2 from the top going to the visual cell. So I want to do that. So I press F5. This time I'm going to inject that 0.57 cc's. So I injected that 0.57 cc's back to this visual cell. Now I'm going to close all the valves. I'm going to close valve 1. Okay. I'm going to close valve 4. So sometimes when you do this, it asks you to give a bubble estimate of the bubble point pressure. This is just the estimate, so I can give any number. I gave 2000 for now. This is for a recombination calculation that we will discuss in chapter 12. Okay, so for now, don't worry about it. So again, I'm gonna close valve 11. I'm gonna open valve 8. Okay, so what I did, I removed 0.5 cc's of mercury and I ejected it into the CO2 tank, and I wish the 0.57 cc's of CO2 has gone through this. Now that I added that 0.57 cc's, I need to shape the cell. I press F6. Remember, every time we add or we remove the mercury from the cell, at the end of the steps, we are shaking it to make sure everything is at equilibrium condition. So you had 10 cc's of liquid first. Now you have 10.57 because you add 0.57 cc's of the CO2. Okay. So to make sure that's correct, I press F10. Okay, and it tells me that, hey, now you have N-butane and you have the CO2. I wanted to generate a mixture of 90% N-butane, 10% CO2, but I got like 90.5 and 9.94. You know, I have a little bit of inaccuracy in this, and that's basically fine because of that. You know, I already said we found this number based on the linear interpolation. And this 0.57 cc turns out to not be 100% accurate. So, but it's fine. Okay. So now that I have the mixture, what I need to do is to find the bubble point pressure of this mixture. And when I have the bubble point, I can find the composition. So in the next part, we are going to find the bubble point pressure of this mixture.